In about 600 BC, mathematicians in Greece began representing numbers with dots arranged in geometric sequences. For example, the figures on your screen show how they represented the sequence of square numbers. These figures reveal how the square numbers got their name. The square numbers are the numbers that can be represented by dots in square arrays. Yesterday we talked about multiplying each counting number by itself, or squaring each number. Each of the squared numbers can be written with an exponent, as it's written here. 1 to the second power, or 1 squared, equals 1. 2 squared equals 2. 3 squared equals 9. Or it can be drawn as an array, like we saw on the first screen. 2 squared is 2 by 2, which equals 4. "25" is a square number. On the left we have an array, which is 5 by 5, which equals 25. 25 is the square of 5. So 5 times 5 equals 25. 5 times 5 can be written as 5 squared equals 25. Now if we want to work backwards, starting with 25, we say that 5 is the square root of 25. So the square, I know most of you have seen this symbol already, the square root of 25 equals 5. And what that tells us is this: 5 times 5 equals 25. A square root of a number is a number that when multiplied by itself equals the given number. So the square root of 36 is 6, because when 6 is multiplied by itself, it equals 36, which is the given number here. So a square root of a number is a number that when multiplied by itself equals the given number. Every positive number has a positive and a negative square root. So since 36 is a positive number, I want to find the square root of 36. It can equal positive 6 and negative 6. And we know from previous lessons, if we start with negative 6 times negative 6, a negative times a negative equals a positive. So our answer would still be 36. The symbol used to represent a square root is called a radical sign, and that is this symbol. And it's read, the square root of 36 equals blank. The number under the radical sign is called the radicand. So the radicand in this example is 36 because it is under the radical sign. Okay, some practice problems. Let's find the square root of 81. So we want to know what number squared equals 81. So 9 times 9, or 9 squared, equals 81. So the square root of 81 equals positive negative 9. You may be asked to find the negative square root of a number. For example, what is the negative square root of 16? Well, we know the square root of 16 is plus or minus 4, positive or negative 4. For this question, they're asking for the negative square root. So we're going to take the negative one, which will be negative 4. You may also be asked to evaluate equations or expressions that have a square root sign in them. For example, 2 times the square root of 64 minus 18. So in this example, we have multiplication here, we have a square root here that we need to find, and we have subtraction. So we're going to start by finding the square root of 64. The square root of 64 is 8. And then we're going to bring down everything else to write our new equation. So we have 2 times 18 minus 2 times 8 minus 18. Remember, if you have a number that is right up against the parentheses, that means to multiply. So 2 times 18 is 16. Bring everything else down. 16 minus 18 equals negative 2. So our answer for this equation would be negative 2. One more example. Find the positive and negative square root of 25. So the square root of 25, what number squared is 25 is 5. So it would be positive 5 and negative 5. You have 4 problems to do on your own. The first one is asking you to find the square root of 169. Number 2 is asking you to evaluate the expression. Number 3, you need to evaluate again. And number 4 is asking for the length of the sides in the square that is drawn. So remember, a square has 4 equal sides. They give you the total area is 9 centimeters squared. How can you find what the side is using what we learned during this lesson?